Hi, this is Eric with Technically Speaking at Source Allies, and today we're going to be talking about property testing. What exactly is property testing? Well, property testing is a field of theoretical computer science concerned with the design of superfast algorithms for approximate decision making where the decision refers to properties or parameters of huge objects. Or, as I'm hopefully going to be explaining today, just a different way of writing your unit tests. So, if you like writing tests, and in those tests you find yourself having to generate a lot of fake data, maybe you've used a library such as Faker or Chance or any one of those things, because at the end of the day, you really want to just search for equality. It doesn't really matter what exactly the fields are. That's for the other kind of tests. Well, property testing hopefully can help with that. Beyond all of this mathematical jargon, basically, it will help you by generating a lot of random data and testing your application a bunch of times with a bunch of different inputs to make sure that it's correct. And it'll use math to try to do that in the most efficient way possible. So today, I'm going to be talking about a library called FsCheck. So FsCheck is a random testing library for .NET, and it's primarily based around F#, but you can use it in C# also. And it's sort of based on the very popular library called QuickCheck from Haskell. And there are tons of different implementations across different languages. So today we're going to be talking about FsCheck. You can see right there in the title, they got random testing for .NET. Instead of just doing what Faker and Chance do and generating a single value for that test run, you'll define the properties of your test, and FsCheck will run them a bunch of times and try to narrow down on any potential failures. So, if, for example, you have something that's working on numbers and it's running through the test and it gets to like, oh yeah, your test doesn't work on the number 50. Well, it will try to shrink that value down into a new value and run your test with that and see if it can narrow down to exactly what causes your test to fail. And that's what separates it from just the libraries like Faker or Chance. So to start out with a demonstration, I'm going to be talking about something that hopefully people are familiar with, the properties of addition. So this is something that you might have learned in school. If not, I'll talk about it briefly here. But the addition operation has a couple properties that define basically how addition works. So I've got up here, there's 5 of them that this website lists. The ones you're probably more familiar with are the commutative and associative properties of addition. If we go down and see what those look like, we can see that the commutative property basically says that the order of the arguments does not matter. So whether you have A plus B or B plus A, they'll always be equal. So over to the code. So over here, I have just a basic XUnit project set up with F# and I've got FsCheck installed. So if you're familiar with XUnit, you're probably familiar with the fact attribute. And then you set up your test, and it doesn't take any parameters, and then you'll maybe do something like expected equals, I don't know, 50, and then you'll have let actual equal whatever, system under test with, I don't know, some random value. Let's just do like 69. And then we'll do some assertions. We'll do assert equal or empty, I don't know, whatever. This is kind of how your tests will look like. Now with FsCheck, they look pretty similar, but there's a few key differences. So first we'll pull in the property attribute over here that will sort of take the place of the fact attribute. And we'll clean this up. And since we're letting FsCheck generate the data for us, we will take those as parameters. And we'll start by testing the commutative property of addition. So, property, there we go. So, in order to test this, FsCheck expects that we return a Boolean value, and that is what it will use to determine if the property failed or succeeded. So for the commutative property, looks nice and simple. A plus B equals B plus A. Go, and if we go over here and run this quick, what FsCheck will do is it will go off and it will run this property many times, in this case 100, that's the default number, and make sure that this property always returns true. So there's a bunch of mathy stuff going on, but at the end of the day, it's kind of just a fake data generator, and it's a really smart one. So now we want to take this a step further. So FsCheck can fail, and what do those properties look like when they fail? So let's create our own custom addition operator, and for starters, we'll have it just do the same thing, and we can update our implementation down here to use that new operator. And when we run this, it should be more or less the same. Nothing will happen. All right, there we go. Still passes. How does FsCheck actually generate the data? Well, we have what's called the arbitrary, and the arbitrary is a combination of a generator and a shrinker, which are responsible for producing the values that will run against your properties. So the generator obviously is going to produce values, and the shrinker, when your property fails, the shrinker is going to attempt to find the next smallest value in order to narrow down at the most specific case that causes your property to fail. So we'll just throw in this little arbs thing that I've got, and there's a little bit of boilerplate going on here. But effectively, all this is doing is just a static member to make FsCheck happy. And we have the generator, or the gen computation expression, and we're using the arb to produce an arbitrary from the generated value. So how are we constructing this? We're just taking the defaults, and we're generating an int. And down here, we are doing the modulus to keep it under 100, and just spitting that back into the generator. So, how do we use this? Go to our property, we assign the arbitrary field, and we give it an array, and we'll do type of arbs. There we go. So, when we run this, everything should work the same. Give it a second here. There we go, passed 100 tests. All right, so we kind of understand arbitraries. So what happens if we throw a wrench in the mix? So currently we've kind of hijacked the built-in addition operator, but what if we did something like if a is greater than 25, then we'll do a random value, else a plus b. So now when we run our tests, we should see that yes, they do in fact fail. So FsCheck has been able to falsify our property, and after 59 tests, it was able to figure out that the combination of 26 and 6 was enough to falsify our test, and that does match up. We checked for 25, and it was able to falsify it using 26. That's all well and good. We can see that FsCheck can generate a bunch of random numbers for us and hopefully shrink down our properties to falsify them. You might be thinking that, well, that's all well and good, but in my job, I don't write addition operators. I write line of business applications, and I write forms in React, or I write CRUD REST APIs, and I don't get to do simple things like this, so how do I define properties for my application? Well, we can approach this from a slightly different angle. Like I said, at the end of the day, it's kind of okay if you just treat FsCheck as a random data generator library. So all of the current unit tests that you have can probably be pretty easily translated into properties, even if they're not, the most accurate properties out there. So over here, I've got a nice little enterprise FizzBuzz module. I have the exact same arbs class, the same int method on it. And over here, I have the repository because, of course, every CRUD REST API has to have an iRepository. And it's just got a single method list, which doesn't take any arguments, and it returns a sequence of integers. And if you're not familiar with F#, seq is basically just iteruntable. So over here we have the service layer, because of course that's going to depend on the repository, and it has a single method greater than, which takes an integer, and it's going to list all of the numbers from the repository, and it's going to filter them down to the ones that are greater than the value given. And finally we have our test. So it looks pretty similar to the other one. We have our property, and we're giving it our arbs instance, and we're going to assert that it properly filters data. So FsCheck will give us more than just primitives. So here, we're asking it to give us an integer array, and similarly, the value to check against. And we're newing up our service, and for the repository, we're just going to return exactly what FsCheck gave us, just to make things simple. So now we call our greater than method, and for any filter operation, pretty much the result should be less than the original value. Otherwise, you're not really filtering anything, right? So if we go over here, and we run our test, we should see that, oh, well, it failed. That's kind of interesting. Well, if we go down here, we can see that it was able to tell us that, with an empty array and 0, our property was false. That's because, well, if we don't have anything to begin with, well, then it could be equal. So we had an error in our test. Let's run this again. And look at that. We're good to go. So we can now run properties in FsCheck and basically have it find our bugs for us. If you don't like writing in F#, this is all going to work in C# just fine as well. And if you don't like writing in .NET, there are many other libraries out there that do a very similar thing, usually having a quick check or some variation of that in the name. This has been Eric with Technically Speaking at Source Allies. Do you have a topic that you want to see covered? Comment it down below. Check us out at sourceallies.com to learn more about us. Thanks for watching. I'll see you next time.